Welcome. Last time we considered simply support beam of span 10 meter with UDL of 20 kN per meter and a point load 50 kN. I gave 5 different positions for that point load. I remember last question number 1, subdivision. See, I wrote critical question for UDL with point load. Actually, UDL over entire span and just one point load. What all principles we are considering here in this class? After covering 5 questions and after all the 5 questions are over, in one more class, I am putting or I will write SFD BMD for all the 5 classes here, 5 questions here. And I will tell you why those 5 examples are considered. Those who thoroughly go through will surely agree with me, yes, it is really a critical question. Lot of concepts which you are getting later when a point load comes in between UDL, that regarding the BMD shape, how it will turn and how the curve will go up and down, all that everything will be considered in these 5 papers. 5 questions. And here 2 questions are specially set by me. I adjusted the load position so that it will give some odd, not odd actually, some special type of SFD and corresponding BMD. So you will learn everything there. And class 1, question 1 over, question 2 was, I gave a word last time, the load 50 kN at 3.6 from right end, UDL 20. So first you require reactions. So first get support reactions. Support reactions. See, one small point. Get it. Get it. That's all. Now, start SFD BMD. I wrote the beam here neatly. See, today I wrote everything because it is nothing but previous question duplicate, little change. So 118, 132, distances are marked A, B, C. Okay. Now, sometime people will tell, not explaining how to find reactions. They should tell in front of me. How many times I explained all these things? I have not gone through. That is your problem. I told every class you should go through and understand. And sometime if I explain too much, people will be there. He is telling unnecessary, he is prolonging it. Okay. Or if I cut short, he is not telling anything. See, in this world, it is not possible to satisfy everybody. You go to that end, this end people will start commenting. Come this end, they will start commenting. But I do not care about those things. I know how to teach and I am taking the class and teaching the way I want it. And anybody, if they start commenting too much and telling this way, I will tell, who asked you to go through my classes? Did I ask you personally? No. Those who are interested in learning, they will realize or they will understand what dedication I am giving, how much effort I am putting to give knowledge to everybody. They will understand and learn. That's what I want. Okay, I'll start now. First, shearing post diagram. See, shear post calculations, actually you know it, not required as a professional, for a professional. Why? Because he wants SFD BMD. He does not bother how is the calculation. But I told academic points also should be considered. So for that reason, I am showing calculation. Shear post, just to right, come to A, no just to right. 1,000 times told. If you come to A, slightly come inside, plus 118. Shear post at C. Just a minute. Okay. Shear post at C, just to left, plus 118 minus 20 into 6.4. Just to right, same value, minus 50. Just to right of B, just to left of, or at B, just inside. Whatever the value you got after just to right of C, minus 20 into 3.6. I wrote everything. If I explain now, some will comment. You told it already so many times. We are not that much weak. We are also knowing everything. We also have got brain, so we can solve. Yes, good. So, shear force variation, linear from A to C and again C to B. Note, I will tell in the class, go back and draw the diagram. See, I am drawing now in front of you. Go up by 118, come down by 20 into 6.4. It will come to minus 10 now. See, last time I will tell you what happened is, it went up here, it came back up to here, then still you are above the baseline, then SFD crossed the baseline somewhere there. Now it will cross the baseline before C. Before that point. See next two questions. It is very special cases. I set the question for that one. Then one more case where shear force diagram will cross the baseline under the load only. All cases are covered. Between A and C today, today means this class. Between B and C, last question, 1. 3 and 4 are special. 5 under the load, over. Now, come down by 50, 60 will come. Go back, go further down by 20 into 3.6 and then 132. Draw the shear force diagram. Now, note, you are right. Go back and draw the shear force diagram. Drawn. Observe the shear force diagram. Your answer, observing. Is there any point where SFD crosses baseline? Yes. Do you know that point? No. Then locate it. Name it. Say D. You are right there. Let the shear force be 0 at a point D between A and C at X from D. X from A. If that is X, this distance will be 6.4 minus X. Okay. Then get the value of X. Similar triangles. 118 divided by X equal to 10 divided by 6.4 minus X. Your X will come. X will come. I will calculate. What is there? Then someone will comment. You did not get the value of X. Still you got that maximum BM. How? I told you. Tricks are there. 5.9 meter is X value. Okay. I will enter X equal to 5.9 meter. Okay. Next. Second option. Directly X. I told mathematical part. 118 divided by 118 plus 10 into 6.4. Or shear force here equal to 118 minus 20 into X equal to 0. Do whatever you want. Get X. Class means go back and enter. How much? 5.9 meter. I am rounding off to show calculated. Or the 6 minus X, I will round off that also. Okay, 1 minute, little more neatly. D, A, D come down. I tell D come down. Okay. This is 6.4 minus X will be equal to 5.9 means 0.5 meter. 0.5 meter. I will round off once again that also. 0.5 meter. Correct 0.5? Correct. Someone should not comment. Wrong calculation. Okay, over. Now, BM calculation. BM at A, 0. BM at C, look this side. Plus 118 into 6.4 minus 20 into 6.4 into 6.4 by 2. Or, those who want, I wrote there. Look this side. Plus 132 into 3.6 minus 20 into 3.6 into 3.6 by 2. Okay. BM at B, 0. Note, class, I am telling now, not over. We have to also find the BM where SF is 0 at point D required. So also BM at D, look this side. Plus 118 into 5.9 minus 20 into 5.9 into 5.9 by 2 will come plus 348.1. Or those who are this side, little extra calculation. Plus 132 into 3.6 plus another 0.5. Minus 20 into that length will be how much? 4.1 I think, yes 4.1. 4.1, yes 4.1 into 4.1 by 2, lastly minus 50 into 0.5. It will give same answer. Then BM variation. A to C parabola. Remember, when you decide the variation, located points are not considered. I will tell once again later. Some people will tell A to D parabola, D to C parabola. I will tell what A to D and D to C. Where is D in the beam? That is where shear force 0. That is secondary. No. Variation is always between standard points. A to C, single variation, one single curve. If a point load is there, then it will change. See, A to B is not single. Why? There is a point load here. A to C, one expression, and B to C or C to B, one more. Parabola, parabola. Then, start. At C, we got 345.6. At this point, we got slightly more. See, I will tell in the class sometime. Slightly more. 348.1. So, if I mark to scale 345.1, that is how much? 3 point something will come somewhere here. Then I cannot show it properly. So, little exaggeration. Now, very important. A to C, one single curve. It should go this way, reach the peak value at this point, then slowly will drop down. And if you draw a tangent here to this bending moment diagram, the slope should be 0. In the last class of this series, I will explain everything one by one in the board with what you call is magnified views. And I will tell so many finer points there. That particular class is going to be longer, not like today's class. Okay. Then B to C, one variation. Now, again important. See, here not possible. I will tell you somewhere here. Okay, all calculations over now. All over. Yes, anything. Nothing left out. So, for your information, I will give some extra information for you now. For those who are interested. See, I will remove this one all. Some little extra information. See, I will tell the correct principle now. See. Shear force diagram I will draw here to understand. See, just roughly. See, 0 shear force. Here, this side shear force is 10, this side shear force is 50. See there? Not 50, 60. Ayyo, what is there? 60. Now, this is the point where shear force is 0. See, here to here. If I draw tangent here, this slope should be 60. And this side when it comes from 60 becomes 10, so it becomes flat. It will become flat, but it will increase here, touch a higher value, then it will come this way. See, now if I draw a tangent here, that slope will be only 10, and this is the point where you touch the peak value, then drop down. Here, bending the tangent will have 0 slope, that is the maximum BM. This is 345.6, this is 348.1. Over. That's how draw it. Thoroughly study and go through repeatedly, understand and get ready for next class where I will consider both the questions, that is 3 and 4, because it won't take much time. 3 and 4 both I will do simultaneously. Together it will take little more than today's class, that's all. Why? Very simple it is. But one important concept will be there. There is one special concept will come there. So get ready for that one. Over. Now, as usual, I told you without even drawing SFD, without locating this point, you saw last time I gave the maximum BM. And last time I talked little, not roughly actually, I told you wanted the answer, I told. Suppose politely asked with me, I will tell. See, I have lot of tricks. Therefore, I will use one of them. What you are asking is maximum BM. How I calculate does not matter. So this question also, I will calculate now. That's all. And one more thing, 100% it is not for show off or to show you that how much I know. People who already know me, they know where I stand. I don't require any new appreciation. If you agree that yes, this person knows quite a lot, then learn from me. That's all. But I am not interested in show off like that. But why I am telling is only one reason. Just to inspire you. I will tell everybody in the class. These all my capacity I am showing, not for show off. Just to inspire you, to motivate you. You should think, if he can do, I can also do. You should get that feeling. Only for that reason, so many times, I will keep on telling, I will show you what is my capacity and how I will calculate. So that even so many students told me, sir, because of that, I learned lot of things. Now, I am also quite good. Then I'll ask for fun. Giving competition? No, sir. No. Competition he don't want to give. He told, not yet reached there. I will tell him, hope one day you will reach there. He will tell, thank you, sir. But he knows what will happen. Okay. Now, calculator required. I will just look at the beam, nothing else. Okay, sufficient for me. I am not seeing anything there. I only looked at the beam, that beam. $348.1 is the maximum BM. I don't know where is that one. I actually know, but no, this will not tell you. Some will tell. Then how you calculate it? Maximum BM is 348.1. You asked me maximum BM, I told. If you want to know where, I can tell. Okay, tell where. 5.9 meter from that end. Then without that one, how you got it? You asked where, I told the answer. You asked how much, I told the answer. Learn, get inspired by me. One fine day, you will understand how I got it. If you are really serious and go through each and everything I explain in this course without skipping one single word, see what happens. Okay. I will continue now in class number 50, half century, where the half century class will be some very special BMD and special SFD will come. So speciality for half century. Okay. Thank you.